This is Stephen Jordan here, doing problem 13.7 for ME 3260. Problem 13.7 asks us to show a system being driven by base excitation through a damping element. Assume the base displacement is sinusoidal with y of t equal to y sine of omega t. Derive the expression for x, the steady state amplitude of motion of the mass m. And for part B, derive the expression for f of t, the steady state amplitude of the force transmitted to the support. The first step is to complete the force body diagram. The force body diagram will look like this. There is it. Both equal to F1. Both equal and opposite F2. And this is also F2. After creating the force body diagram, we have to look at the equation of motion, which comes out to mx double dot is equal to F1 minus F2. F1 is equal to negative kx, while F2 is equal to cx dot minus y dot. This gives us an overall, finishing the equation of motion, we have negative kx minus cx dot minus y dot, making it go to mx double dot plus c of x dot plus kx equals cy dot. Our next step is to take the Laplace transform, which comes out to ms squared plus cs plus k times x of s equals cs y of s. The transfer function then becomes x of s over y of s, which equals cs over ms squared plus cs plus k. When looking at y equals big Y sine omega t, you can put that into the transfer function. To go to x equals x sine omega t plus phi. Big M equals big X over big Y, which equals T j omega, the magnitude of, which equals the magnitude of C omega j over K minus M omega squared plus C omega j, which equals C omega over the square root of k minus m omega squared plus c omega squared. This subs down to c over 2 square root of mk times 2 square root of mk times omega, all over big square root of mk over m minus omega squared plus c over 2 square root of mk times 2 square root of mk times omega squared. Times, so simplifying, we can do a 1 over k times 1 over k. This becomes zeta. This is omega n squared. This is the same as down there. After obtaining this, we can simplify further to obtain omega over omega n all over square root of 1 minus omega over omega n, that quantity squared, times the whole quantity squared, plus 2 eta omega over omega n squared. So we can simplify it by saying r equals to omega over omega n. This gives us the final answer of x equals 2 eta r over square root of 1 minus r squared, quantity squared, plus 2 eta r squared y, giving us the final answer for part A. Now for part B, we have to look at the force transmitted to the support. So we'll look at the force supplied right there on the spring and on the support, which is F1. So we're going to say F transmitted equals negative F1 equals Kx. F of t equals Kx sine omega t plus phi, which was obtained earlier. This equals big F of t sine omega t plus phi. So f of t, after subbing in what we obtained earlier, is equal to 2y zeta, kr over square root of 1 minus r squared, quantity squared, plus 2 that r squared y, giving you the final answer for part B.